We've given the first blockchain application instance the ability to generate a server for other instances to connect to with this listen function. Now we need to make sure that later instances of the application connect to the original one immediately when they specify it as a peer. We'll handle this with a function called connect to peers that we'll call right here within the listen function. So this will handle later instances of the application connecting to peers that are specified when they're started. So call this.connect to peers within the server.on and the console.log of the listen function. Now let's actually add this function with connect to peers within the class for this P2P server class. And now we'll want to run some code for each of the peers within this peers constant array that we have at the top. So let's do peers.forEach, and the forEach function will allow us to run some code on each object in the array individually. And for each peer, we're going to run some code over here within a callback function that goes one peer at a time. Now this peer is going to be something like an address of ws//localhost 5001. So that is what a peer will look like. It's the address of the peer. And with that address, we can make a new WebSocket module, or rather object, by using the WebSocket class at the top and then passing in that peer address into the constructor. So this will create a socket object, just like this socket object that is created with the connection event listener. All right, great. Now, the thing that we have to do immediately once we have this socket is to open another event listener for the open event for this. Because when we specify our peers for the application, well, we might not necessarily have started the WebSocket server at localhost 5001 if that's a peer. But by doing socket.on open, we can run some code if that server is started later, even though we specified this as a peer first. And then we'll have our callback function, and this callback function will call this.connect socket, and the socket that we'll want to connect is this socket object we created manually by making the new WebSocket with this peer. All right, we've completed the basic functionality. For the very last step, let's use module.exports and then assign it to our P2P server class, so that way other files can use it. And now we're ready to use this P2P server class within the main index file for the application. So within index.js, well, let's require our P2P server class. So that's capital P to lowercase p server, sets for the result of acquiring the local P2P-server file. And then we'll create a P2P server instance now right below the blockchain. And this one will be all lowercase except for the S of server, which is uppercase, because this is the conventional camel casing syntax for variable names. And then we'll assign it to a new P2P server instance. And then our P2P server class takes one argument for its instances, and that is a blockchain, which we do have with the BC local instance of the blockchain. So let's pass that in. All right, finally, at the very bottom of the application script over here, we're going to want to actually fire up our instance with its listen function. So this will start the WebSocket server in this blockchain application instance. All right, great. We've added quite a bit of functionality, and it's been a while before we could actually test it, but now we're ready to check out this server in action and see what it can do. So make sure you have all of your files saved, and let's open up the command line to test this functionality. Now in the command line, have one tab open, and in this tab, we're gonna run the regular dev script, and then this starts a peer-to-peer server on 5001, and then also starts an HTTP server for the API on 3001, which are the default port constants. Now in our second tab, let's open a second one. And since the default ports are already taken, we won't be able to run npm run dev normally. We'll have to change the default ports by using environment variables. For example, let's change the HTTP port to 3002. Likewise, let's change the P2P port to 5002. And then we'll specify our one peer because we want these WebSockets to be connected to each other. And the peer is ws colon localhost 5001, since that's the address of the first instance that we started running. And then finally, as our last argument, we do npm run dev. And this will fire up the application with our change process environment variables. As we do so, this time we get listening for peer-to-peer connections on 5002, which was our port. Again, the HTTP server is now on 3002 since we specified that. And look at that. We have a socket connected, which represents the first instance that it found when it opened up its server. And great, if we go to the first tab, which was the first instance that we ran, well, look at that. We get a socket connected. Cool. So we can extend this to a third instance of the application. You can open up a new tab, and again, we'll change the default variables. This time, the HTTP port will be 3003. That one isn't used yet. The P2P port will be 5003. That one's still available. And then we have two peers this time. One is the first one, the localhost 5001 address. And the next one is the localhost 5002 address on the WebSocket protocol. And finally, we run npm run dev for the third instance. As we do so, this time we have two sockets connected, which represents respectively the first instance and the second instance. If we go to the second tab where our second instance is running, well, this time we get a second socket connected printed to the terminal. And finally, in the first instance, yep, again in the terminal, we have a total of two sockets connected. Perfect. We finished setting up and proving the connections for our P2P server now through this experimentation. Let's move on to something more blockchain specific with this connected network that we have. Let's take advantage of this network to send each blockchain's instance to each other through the peers. That way, each instance will share the same blockchain using the one that is longest and the most up to date. Once we have this functionality across our peer-to-peer server sharing the blockchains, we'll have a truly decentralized blockchain application.